got some tech issues right now. James Brierton, normally on with us every night, he kind of does the behind-the-scenes tech stuff with our streams. And, well, James is on Maybe Watch. He's not going to be with us tonight and probably for not the next few weeks, as he and his wife are expecting their first child. So we want to give our best to James and Chelsea and hope that everything goes out good. So Jared is behind the scenes running our tech side tonight. So he just sent us a message that he can't talk about the Charleston weather right now because he's working on something. So we'll skip Jared tonight. I will say here in the Carolinas, if you live in North Carolina, you know we've had all types of season this week. We topped out in the 70s today, but about 3-4 days ago, a good portion of the state, probably 3/4 of the state, was under somewhat snow cover, between a couple of inches in the Piedmont to over a foot in the mountain location. So it's been a very diverse week weather-wise. Thankfully, away, and it looks like we're going to be close to 80 tomorrow, and it looks like it's actually going to be a good Easter week as we stay in the upper 60s and low 70s. So hopefully all of that wintry stuff is done for the rest of the year, because I am tired of it. I know, Shay, even though you guys haven't got snow, I know you're tired of forecasting all the cold temperatures and the wedge and stuff. So it's time for it to go away.
Yeah, well, I mean, April is one of our windiest months of the year, so we do expect the northeast wedges to continue. But the CAT events, the cold air damming that we had the last couple of days, it's like, gosh, we got down near freezing just a few days ago. One thing I do want to mention is that the National Weather Service Charleston did start, and not also Jacksonville, all the way up and down the coast, started their high rip current forecasting on March 15th. So keep that in mind if you're going to the beaches, you're getting out in that spring weather. You want to go to the beach, there's people out swimming today. There's a high risk for rip currents going on right now through this evening. There may be another one issued tomorrow. I'm not really sure. They'll make that decision tonight. They may already have while we're live right now. But either way, keep up with the latest from the National Weather Service as far as rip currents, because we do have conflicting swell with winds, and that creates a lot of turbulence in the waters, especially on the beaches near some of the spits where the currents pull people out to sea. So be very careful if you're on the water. The water temperatures, hypothermia, be mindful of what the air temperatures may be. Prepare for any, cooler climates still along the coastline. And that'll do it for us in the southeast along the immediate coast, Scotty.
All right, sounds good. Well, let's bring in our guest tonight, Todd Lindley, the Science and Operations Officer at the National Weather Service in Norman, Oklahoma. Todd, thanks for joining us again. How's things out in the good old state of Oklahoma?
Well, Scotty, first of all, thanks for having me back after the debacle that we had with the internet outage back in January. It's a pleasure to be back with you guys, and hopefully we can talk a little bit more about fire tonight and have that uninterrupted by technical difficulties. So no pressure there, Jared. But Oklahoma, it's a little cool and wet right now. I'll show my screen real quick and show you some of the rainfall totals from the Oklahoma Mesonet. The last 5 days or so. Most of this started, I guess, probably Sunday evening, and it's been raining the last 48 to 72 hours or so off and on. But good portion of south central and eastern Oklahoma really got a good drink of water the last couple of days. As you can see there, rainfall totals ranging from about 1.5 inches just along and southeast of the Interstate 44 corridor to locally near. Tremendously good news, because Oklahoma has been pretty drought stricken. This plot here from the Oklahoma Mesonet actually shows number of consecutive days with less than 1/4 inch, and that's an amazing 172 days up in northwest Oklahoma, places like Woodward, Arnett, and Buffalo. Way out in the Oklahoma Panhandle near Kenton, 8 rain. So we continue with D4 exceptional drought out in northwest Oklahoma and portions of the Texas Panhandle, and that's where most of the fire activity has been occurring so far this spring.
Yeah, Todd, before we get into your presentation, or else we can do it during your presentation, talk to us about how active it has been out there in your area, especially western Oklahoma towards the Amarillo area.
Well, we've had, starting back in January, we started seeing some fire events here on the Southern Plains. most of them have been relatively mild compared to fire events we've seen back in 2016 and 2017. You know, we've not had mega fires out here on the plains so far this year, but there have been some events. I believe the largest fire we've had on the southern plains so far this season has been about 15,000 acres. It was called the County Line Fire, and it was just to the northwest of Amarillo. Another one actually northeast New Mexico that actually burned in parts of 3 states, far southeast Colorado, northeast New Mexico, and the far western Oklahoma panhandle, called the State Line Fire. That one burned about 26,000 acres or so. But with the rainfall over central and eastern Oklahoma, you know, here's to hoping that we've seen the worst and maybe conditions will start to improve from here.
So Todd, I got a question for you. This kind of drought, what do you think is causing it, and what do you think may break that? Do you think it's just a in between seasons? I mean, that's a long period of time for that little trace of rain.
Yeah, you bet. You know, Shay, when we're in a La Nina type of regime in the eastern Pacific Ocean, that's really a strong driver for drought on the southern Great Plains. And some of the studies that we've done on wildland fire, for instance, in the southern plains, indicate that over the course of a decade, about a staggering 98% of all the acreage burned on the southern Great Plains will occur during La Nina. So that's a tremendous correlation between La Nina, drought, and fire here on the southern plains. So the latest indications are that La Nina is starting to subside, and hopefully things will start to improve as we go through the weeks and the month ahead. But we are technically in the peak of the fire season here on the plains. Of course, the very beneficial wetting rains we picked up in recent days are just vitally important to mitigating that risk in central and eastern Oklahoma.
Sounds good, Todd. Well, we can go into your presentation, and we can go through that, and definitely we'll ask any questions as you go through it. One thing I know that you're going to talk about that a lot of our followers and listeners have been really excited about is the GHOST 16 data. So
you
I'm
bet.
sure that we'll be able to touch on that as well.
You bet. Well, hopefully you're seeing my presentation now, my slides, and just talk a little bit about predicting wildfires in the southern Great Plains. And, you know, really the southern Great Plains, most people think of wildfires, and what do you think? You know, you think the western United States, you think, you know, California and the Intermountain West. This is a chart, I believe this is showing wildfire activity from roughly, I believe, the last 15 years or so. And what you'll see, you know, is most of the fire activity is from the Rocky Mountains westward to the Pacific coast there. But if you look in the southern Great Plains, you do see this kind of localized hotbed of fire activity, western Texas, encompassing mainly the western 2/3 of Oklahoma or so. And those fires that you see there that are yellow with the red outlines, those are actually mega fires. Those are fires greater than 100,000 acres. And we're seeing a global increase in mega fires, you know, across the entire globe in the last 10 to 20 years or so. But that's not just a Western U.S. problem. That's also a problem here on the southern Great Plains. And there are a number of kind of ecological reasons for that. One, changing land usage. We have a general reduction in the acreage of agricultural land now compared to 50 years ago. And more land is going into conservation type programs with native and imported grass species out there. And also, you know, general fire suppression over the last 125 years or so. As a settlement occurred on the southern Great Plains, we started suppressing wildland fire, and that's allowed invasive woody species to move in over the plains: mesquite, eastern red cedar, and juniper. So we're not just talking about grasslands now. We're talking about increasing, you know, shrubby, woody vegetation, which just increases a fire's intensity and decreases the ability for firefighters to suppress that fire. So not only that, but also increasing population across the southern plains. You know, in Texas, for instance, I believe the last time we had a multi-decadal drought like what we've experienced from the late 1990s to about 2010 or so, the population of Texas was more like 7 to 9 million, and now it's about 27 million. So increased population means increased opportunity for fire start, but also increased infrastructure with utility lines and oil and gas industries big out here, and that's a frequent ignition source, if you will, for wildland fires on the Southern Plains. So fire is very much a Southern Plains problem, just as it is the Western U.S. And as I mentioned, here in Oklahoma, we're pretty much in the peak of our season now. We had very beneficial wetting rains in the last few days, so hopefully that will help to mitigate the threat and or kind of speed up the green up process as we go into spring here. But in general, our fire season in Oklahoma does peak in the month of March.
That's an interesting graph, yeah, because it's almost like you could correlate a lot of this with severe weather outbreaks and lightning strikes. But is March your peak season for severe weather? Because it looks like right now there's not a whole lot there.
Yeah, no, absolutely. And that's a great point, because I do want to point out that most significant wildfires in the Southern Plains are not associated with lightning at all. They occur in the dormant season under very dry downslope wind conditions. And usually when we have thunderstorms, it's moist enough around here that we have beneficial rain and wetting rains associated with them. So dry lightning outbreaks like you see in the West are very unusual here. Not every fire season, though, brings significant fire. In fact, if you look at like a 10 to 12 year period, you only see significant fire on the plains about about 1/3 of the years. So, the fact that we've had pretty significant fire activity now, both in 16, 17, and it's still a little debatable just how significant the 18 fire season will turn out to be. But to have 3 consecutive years of pretty significant fire activity would be very unusual. So, just because the grass is dormant and it's dry, the plains do not spontaneously combust or anything like that. But to speak to your point, Shay, about just how analogous these systems are, or the fire events are on the plains to severe convection, this graphic pretty much illustrates exactly that. In fact, most of the fire outbreaks that we see on the Southern Great Plains are caused by pretty much the same systems that spawn severe storms. As meteorologists, though, we're always looking to the east side of the dry line in the warm, moist sector. And of course, for good reason, we're all interested in severe convection and tornadoes. If you look out to the west of the dry line, in this particular case, you see what looks like big convective billowing clouds out there. And in fact, they look something like this, but that's not actually a wedge-shaped tornado. That's the Swenson fire that burned about 250,000 acres east of Lubbock in April of 2011. So a very interesting process that goes on to the west of the dry line too, with these very dynamic springtime storm systems that move across the Southern Plains, these mid-latitude cyclones. To the east, they bring severe storms and tornadoes, and to the west, they can bring very damaging wildfires. So we've been able to apply very analogous methods to those that were pioneered in the 1950s to first study tornadoes and severe thunderstorms, to studying wildfires and learning how to forecast wildfires. And one thing I always like to point out is with tornadoes, about 80% of them are weak. Another 18% or so are strong and may do this type of damage that you see to this structure, remove your windies, but 2% are violent, EF4, EF5 tornadoes that just level your home. But of course, fire is actually a violent form of decomposition. One of the most noteworthy fire historians in the country, Dr. Stephen Pyne, defined fire as a violent form of decomposition. So fire impacts a much larger geographical area as far as footprint and the damage, and also the intensity of the damage is almost always violent. So,
and Todd,
yes, go ahead.
And Todd, I was going to say for our followers and listeners tonight, the Gatlinburg Pigeon Forge fire was a violent fire. If you recall back some of the reports out of that, they compared the damage in the mountains of East Tennessee, the comparable of what you may see out in the Midwest with tornadoes. So those wildfires, like you said, Todd, can cause a lot of devastation.
You bet. And that's a a good example to illustrate the point, but yes, that was a disastrous event as well. So shown here are all associated with this particular day, April 14th of 2011, and this was just kind of a classic fire outbreak on the southern Great Plains. And as you can see, the CWA where I'm from, WFO Norman, you can see our CWA literally split right down the middle near the Interstate 35 corridor, with the severe storms and tornadoes occurring to the east and extreme fire conditions in the west. And that's something that we see pretty frequently. But I just love this quote from Dr. Pyne at the top, that fires are atmospheric events as much as dust devils or hurricanes, which also organize heat release from the surface. So, you know, as meteorologists, many times we like to think about, you know, well, I can tell you what the relative humidity and the wind is, but it's up to the Forestry Service to determine the impact on the fuels. But really, this is all, it's all meteorological. So, and I can make several points to that throughout the night, but it all comes back to meteorology, and fire really is an atmospheric event.
Yeah, and if I could just make a quick comment on that, I spent a huge time in Lubbock, and I will tell you, living in Lubbock, some of the worst wildfire days that we had, or dust days or windy days, were outbreak days. So the big outbreaks, like you were saying, in Oklahoma or in the Southeast, we were getting fire weather. So I completely agree with that graphic. It's picture perfect for what goes on out there.
Yeah, absolutely, Ashley. This is just a little bit of information about these fire outbreaks that occur on the plains. Since about 2005, we've documented 25 of these widespread fire outbreaks, what we call Southern Great Plains wildfire outbreaks, or firestorms. And cumulatively, those 25 events have burned about 5.8 million acres. They've destroyed 2,700 structures, killed 34 people, and injured 220, which is pretty remarkable. Just the scale of fire and the violent nature of the fire that you see during these type of events, 88% of them result in human casualties. So very, very dangerous fire events that we see here on the Southern Great Plains. And you can see this chart kind of showing the cumulative plains fire outbreaks. Interestingly enough, prior to about 2005, if you look at the state forestry agency fire records, you don't see fire on this scale in the Southern Great Plains. You don't see any individual events that have fire on the scale of the events that we've seen post 2005. So it's almost like we've met a threshold there with land usage, population, and seasonal variation or climate changes that have kind of facilitated this type of fire on the plains.
Now, Todd, I got a question. Like these fires seem to spread very quickly. What is the main driving mechanism? I hear of Chinook winds in the plains a lot, and where you're talking about in these areas, is this a downslope sort of adiabatic heating process where the winds are really cranking through there and spreading these fires very, very fast, or what is the main driving?
Yes, Shay. Usually, this is the picture-perfect textbook fire scenario on the Southern Plains here. This is what we call the composite map for a Southern Great Plains wildfire outbreak. And you can see it features, like we saw in the visible satellite image, the ejection of a strong shortwave trough or mid-latitude cyclone ejecting over western Kansas. And to the south of that, you see these very deep, very intense wind fields. They're at 500 millibars, or about 18,000 feet above ground level. 70-knot wind max coming across West Texas. I can tell you from experience, I think that's showing 70 knots because of the spatial averaging that we did to get the composite map. Usually these individual events, if you look at them, they range anywhere from some 60 knots, but usually the most dangerous events have a mid-level speed max of about 100 to 120 knots or so. And of course, that translates down to the surface. You get sustained winds of 30 to 40 miles an hour, usually, sometimes in excess of 40, with gusts around 60 to 65 miles an hour, not uncommon in these type of events. So you actually see a rate of spread for fire. A lot of people think that the fire literally spreads at the rate of the wind, but that's not true. The fire propagates, through the vegetation. One of the I guess I should say the fastest confirmed rate of spread that we have observed on the Southern Great Plains is about 6.5 miles an hour, which is still pretty significant. You're covering the length of a football field in well less than a minute. But if with the goes 16 imagery and some of the fire events that we saw last year with it when it was experimental seemed to suggest that we might have had some 1 hour periods in there. We were seeing rates of spread in excess of 10 miles an hour, and we'll show some of that imagery. But just to make one more point about one of these fire outbreak bearing weather systems, they're very anomalously warm. And if you look at the dates, all of these are in, you know, late winter to early spring, but yet you see on average the 80-degree isotherm extending all the way into central Oklahoma. So very unusually warm, very unusually intense wind fields, and very, very dry back in to the west of the dry line, south of the cold front. Now, that composite picture kind of shows us the synoptic scale that's favorable for these type of fire outbreaks. So when we start to recognize that big picture weather pattern coming across, and of course, those are pretty predictable features, you know, a big mid-latitude cyclone like that ejecting over the plains, many times we can see them coming in numerical weather prediction 5, 6, 7 days out. But when we start to see that, it doesn't really tell us exactly what portion of the plains is at greatest risk, whether it be eastern New Mexico or eastern Oklahoma. So what we start to focus in on are these temperature anomalies. So what we found time and time again is that the fire activity tends to congregate where temperatures are +5, +10, +15 degrees above normal. And more specifically, they tend to, you really get these conflagrations where you have this low-level thermal ridge, either at the surface or around 850 millibars, being overspread aloft by intense mid-level speed max at 500 millibars. So in this case, from April 9 of 2009, that's a day we burned about 250,000 acres across Oklahoma, central Oklahoma into northwest Texas. On this particular day, you can see all the fires are aligned along the low-level thermal ridge, but specifically where the 75 knot, 500 millibar speed max is intersecting that low-level thermal ridge. So we've been able to use that going forward as a strong predictive signal for forecasting specific areas up to 3 days in advance where there's a heightened risk of very damaging wildfire. And just like you were asking, Shay, about, you know, what is the process that occurs there? And you mentioned Chinook winds. And it's not exactly the same as a Chinook wind, but it's very similar. So this is an instance of the Anderson Creek fire. You can see the fire in the dry wedge there. The clouds, if you can follow my cursor there, these clouds up here, that's actually associated with a blizzard on the Front Range of Colorado. This linear cloud feature here, that is actually the cold front sweeping south through the Texas Panhandle. This right here is the Anderson Creek fire in March of 2016, which burned about 360,000 acres. And it, at the time, was the largest wildland fire in Kansas and Oklahoma state history. Back here to the southwest, you can actually see a couple of other damaging fires in the Texas Panhandle just south of the cold front. But this area right here is what I'm referring to as the kind of the warm, dry sector of this particular cyclone. So if we take a cross section across this storm system from the blizzard in the Front Range of the Rocky Mountains east through this low-level thermal ridge where the fires are occurring, what we see, if we look at the potential lines of potential temperature, the isentropes, they're generally slanting down, and then they get into the low-level thermal ridge and they fold right into the surface. So if generally the air, the wind along these isentropes, it's similar to the way we get, you know, isentropic upglide or ascent with a warm front, except it's the exact opposite. Here we're channeling the mid-level flow aloft right into the surface, where the temperatures happen to be, you know, the warmest, relative humidity is the driest, and the lapse rates are dry adiabatic through a very deep portion of the lower parts of the atmosphere, just allowing that momentum to transfer down to the surface.
Now, Todd, do you guys have vertical profiling active over in your neck of the woods, or do you just go by your soundings?
Well, we a number of things. We use soundings, of course, and pretty high resolution modeling of this. We can usually see this process. We can actually see the coupling of the mid-level kinematics with the low-level thermodynamics play out in high resolution models like the HRRR. You can watch it play out. You can see the coupling and the decally get the fire effective time window for a system like this down to, you know, a number of hours when that coupling is occurring. The one part of the equation that we haven't really discussed yet are the fuels. Talked a lot about the weather, but I've got some other great quotes from Dr. Stephen Pyne in here. Fire is a climatic phenomena. Climate determines the potential for fuels and vegetation. And you think about it, why are the fuels there? You know, the fuels and the vegetation really are a biospheric reflection of climate and seasonal variation and weather. It's the cumulative effect of weather and seasonal variation over time that create the fuels and shape the fuels. So what we use here on the Southern Great Plains, we use a value that's part of the National Fire Danger Rating System called the energy release component. And if you're into severe convection, you know about CAPE, convective available potential energy. ERC is really the fire equivalent of that. It's telling us the potential energy available within the fuels for burning. So we can look at this value, and we know we have statistical studies that show that if the ERC values are near 60, very large fires greater than 5,000 acres are in the realm of possibility. But if we have, you know, ERC values only of 30 or so, we're really shy of the parameter space that results in these very large damaging fires. Not to say we won't have fire. You could have some lower end fires, you know, upwards of a couple hundred acres, but you know you're not going to see a 5,000, much less a 10,000, 100,000 acre fire in that kind of environment. And this is just an example, actually, from Ashley's neck of the woods down in Central Texas, of the energy release component back during the spring of 2015, when we had very dramatic swings. Austin went from flooding rains in late May. The ERC was down to zero. You could not start a wildland fire if you tried. As you can see, large areas are underwater. But then through the course, what the ERC does for us is it models the vegetative response over time. So you see the drying out from the floods, and then the buildup of grasses and vegetation that resulted from that rainfall over the course of the summer, and then finally get to a point where the summer heat drying things out, and you get to a very volatile fire regime by October, and they're called the Hidden Pines fire near Bastrop. And then lo and behold, within a week later, you have flooding rains come in again, and you can see that ERC value respond and go back down near zero with no threat of wildland fire. So it is a tool that we can use to see how the wildlands are broad periods of time to the moisture and to the weather.
So I had a quick question about that. So you said around 40 to 60 ERG or ERC is what you would look at for wildfires, correct?
Well, these are raw values for a single location, so take them with a grain of salt. The best way to do this is to normalize it using percentile rankings. But in this particular study of this area of West Texas, you know, you start to see the more significant fires once the ERC gets upwards of 60.
Yeah, that was going to be my question. So it's just for the Panhandle, that's not for Central Texas?
Those particular values would be, you know, and how they would relate to fire would be different if you looked at Central Texas. But what you want to do is look at the percentile ranking and see how anomalous those ERC values are. In general, the 60 raw ERC value that you see here in the Texas Panhandle is near the 90th percentile in the Texas Panhandle. But in Central Texas, the 90th percentile may be more like 40.
Okay, thank you.
So in general, fire, what we call critical fire weather, which is usually what meteorologists refer to as some combination of relative humidity and wind, it really is a moving target. You know, if the fuels are really volatile, you may see significant fires occur, say if the relative humidity gets to around 5%, but the wind's only 15 miles an hour. But in less critical fuel environments, you may need much stronger winds or lower RH to get fire. So, but really, you know, a 30% relative humidity with the sustained wind near 40 is the same as the 5 and 15 mile an hour that we just discussed to a fire. So it's really a moving target. And, you know, generally as the strength or the fuel moisture increases, a fire's resistance to control will also increase. So as the fuel moisture goes down and down and they get drier and drier, then, you know, you need less weather. conversely, you know, if you have higher fuel moisture, you're going to need much stronger weather to result in significant fire. And we can actually plot that out by combining a couple of parameters, the energy release component and another parameter called the red flag threat index, which is nothing more than like it's the quartile ranking for combinations of relative humidity and wind. But you can see that that plot, you actually get a pretty high correlation and a polynomial regression here with the combination of those parameters. And that's basically, you know, we can use that as a baseline to forecast the types of fires that we may see on any given day. Now here's the exciting stuff with GOES 16, and we were talking a little bit about that. The animation that you're seeing here is from the firestorm that we had on March 6th of 2017 on the Southern Great Plains, affected portions of southwest Kansas, northwest Oklahoma, and the Texas Panhandle. This was an amazing and historic event. We had 1.2 million acres that burned on this particular day across the Southern Great Plains. But what we're seeing is the GOES 16 imagery is really revolutionizing the way the National Weather Service does fire services. One of the new things that we've implemented here at WFO Norman is when we start to see indications of a newly emerging wildfire in the GOES 16 imagery, we will send its geolocation and the proximity weather conditions for that fire to first responders and basically provide an initial detection type of capability for the first responders. In the first year that we did this was in 2016, and 78% of those notifications led to a 5 to 15 minute advance notice over local 911 calls. So that's a dramatic service. I can tell you the feedback from that we're getting is will just blow your mind. Frequently getting comments from emergency managers, officials, how, you know, this is saving lives and property across the Southern Great Plains. And that application that we developed here in Norman has been shared with about 31 other forecast offices around the country now. I can't speak to, you know, which offices are using it and which ones are not, but the capability to do that is spreading around the country. And this is just one more kind of testimonial of that service. This is kind of what the output looks like in the lower left. A couple forecasters actually at WFO Norman and a Texas A&M Forest Service fire analyst that was deployed at WFO Norman at the time, both looking at this fire developing on the monitor here and looking downstream to see, you know, what structures may be threatened. And this is an amazing quote from a fire chief in West Texas with more than 30 years of experience, saying that the NWS hotspot notification is one of the 5 greatest developments in his career, right up there with the jaws of life. So that tells you how beneficial that tool really is. And I know a press release from just last week saying wildfire season on the Southern Great Plains is off to a strong start, and that hotspots are detected earlier than ever thanks to NOAA GOES East, which is formerly known as GOES 16. This is just another animation showing that March 6th storm, pretty remarkable. And this fire here was the Perryton fire, became the 3rd largest fire in state history in Texas. And if you watch when the wind shift hits it on the evening of the 6th, you see this head fire start to go towards the south right there down the Canadian River Valley. It appears, based on the GOES 16 imagery, we might have had rates of spread of about close to 10 miles an hour for a short period of time. As far as some of the fire activity we've had this year, like I said, most of it has actually been on the high plains of West Texas and eastern New Mexico. We have had some fire activity in Oklahoma, but this was an event from March the 18th. And you can see a classic fire situation where you have a strong storm system crossing the Colorado Rockies, ejecting into western Kansas. And even though you don't see widespread fire activity in this case, like we saw in some of the examples I've shown, you do see one isolated large fire near Amarillo. And this is an image of that fire. And this is actually the hospital district on the northwest side of Amarillo, and the fire is moving in, threatening actually the medical areas of the complex and northwest side of Amarillo. So a few scary moments there. But if you actually look to the northeast, and the northeast Texas Panhandle moving into northwest Oklahoma, that's severe thunderstorms, severe convection. And this is a tornado that occurred near Spearman in the northeast Texas Panhandle with that same system. So that tells you how dynamic these systems are. You have fires near Amarillo, and just even within the Texas Panhandle, you know, some 90 miles away, you have tornadoes.
Todd, question real quick. Looking at these pictures, we always hear that fires create their own atmosphere or their own weather. Can you elaborate on that a little bit?
I can, just a little bit. There was a research study done in Central Texas several years ago called Fireflux, and what they actually had some prescribed fire that they moved through some specially built mesonet sites, basically to measure the effects of fire. And you know, they found some very interesting things. For one, the wind. Probably the most striking result that I've remembered. The wind associated with the fire front can be 3 times the ambient wind speed. So very strong winds associated with it. Of course, it's very, very hot. These things burn on the southern Great Plains. It depends on the intensity of the fire and, you know, the condition of the fuels that it's burning in. But in general, here on the southern plains, they burn at about 1,300 degrees or so. Very warm, burning temperatures. And another thing that's interesting, when we've had mesonet sites that had burn-throughs, what we frequently see is you see an evacuation of what little vegetation there was in the on the surface or in the vegetation. You can see that evacuate immediately in advance of the fire front with like a miniature little spike of relative humidity and dew point immediately before the fire front passes. So you know, they are very much dynamic atmospheric events. Like I hope to show here, you know, they're a result of a coupling of the atmosphere with the vegetative boundary layer at the surface. Does that kind of answer the question, Shay?
Yes, absolutely. I mean, I'm sure each different region has its own, you know, the fires have their own sort of weather they create. I mean, like Hood River, Oregon would be an example of where you might see some of that funneling effect, or, you know, valleys, peaks and valleys, and some of the other areas where fires may occur. You know, California is another example. We see the wildfires over there, and it seems like every region is a little bit different from each other as far as how they go. But there's some impressive slides that you did there, and I got to say, if John Jensenius is to lightning like you are to wildfires.
Todd, I have a question for you. For getting the word out, as you guys are in the Norman office for your forecasting, I know the Storm Prediction Center, which is there at the National Weather Center, they issue fire weather outlooks. I think a day 1, day 2, and then day 3 through 8, I believe is what it is. And then you guys also issue like red flag warnings and stuff like that. Can you kind of talk to our viewers about those different products, and if one's issued for their area, maybe what that those advisories or whatever may mean for them?
Sure. Yes. Well, you're correct. The Storm Prediction Center issues fire weather outlooks for days 3 through 8, and of course day 1 as well, that basically just indicate whether the fire weather will be elevated, critical, or extremely critical for a given area. And that's a good, you know, indicator to folks that, you know, if they're interested in such things and they want to know, you know, just how critical the fire weather conditions are on any given day in the outlook period. At the WFO, at the National Weather Service offices, we issue fire weather watches, generally about, you know, can be as far out as 3 days in advance of a potential event. And those just indicate that conditions are becoming increasingly favorable for extreme fire behavior, or also new ignitions, new wildland fire ignitions. And then once we get within about 24 hours in an event, we will generally, you know, if the forecast remains on track, we'll upgrade to a red flag warning. And a red flag warning is kind of a unique beast in the National Weather Service. You know, everything else is tornado warning, winter storm warning, flash flood warning, and then we call this a red flag warning. And it has a unique history. It was basically a firefighter safety message, is how it originated out in the West, where many times in the fire season in the Western U.S. you have fire always on the ground out there, and it was a message used to communicate to firefighters that, you know, at this particular time and space, the fire will likely behave in an extreme way, and it's a safety message for you to take precautions. Certainly here on the Southern Plains, now the red flag warning has morphed more into a public safety and, of course, a land management and fire management product as well. So the National Weather Service is looking at that in the future, trying to determine, you know, is there a need for public fires, and what venue would we use to communicate that. So that's an ongoing effort to maybe modernize the fire weather program. Now, sometimes when we get into these very active extreme fire situations, we have what's called a fire warning. And a fire warning is a warning that we can issue at the National Weather Service at the request of a local emergency manager that needs to communicate, prompt a mass communication of evacuation instructions. So say a wildfire is approaching a town or a community, the emergency manager can ask us to disseminate a fire warning with detailed instructions for how folks should evacuate.
I have a question about that because I'm in emergency management. So how often is that utilized? Because I know we have our own evacuation warning systems and our own ways to do all of that. How often do they rely on that?
It differs depending on the season and the severity of the fires that we see in any given year. I know that event that I showed you images, I believe they issued 2 fire warnings during that event. I've also noticed that use of that product is not very consistent around the country. Some areas where they have, you know, I don't know if it's relationships with the emergency managers or just cultural knowledge of that capability. Sometimes you see those issued in some parts of the country, and in others you don't. It does seem that here in the Southern Plains, it seems to be used more common.
I want to pick back kind of Ashley's question. When you do have these events going on, what is the role of the National Weather Service? Are you? I know you guys do decision support. Are you there communicating with them? Do you give them updates for the Weather Service when we do have these big fires?
Wow, that's a really great question. So there are several parts to that. I would say historically, the National Weather Service in fire has been strategic. Our role has been to identify periods or days that are going to have extreme fire behavior due to weather, combinations of weather and fuels, and issue red flag warnings. And then those really prompted strategic preparations by fire and land management. And maybe they would allocate resources to a certain area for a given period of time so that they're available to assist and help, you know, mitigate public impacts. But now, especially with GO-16, our role is really transitioning from not just strategic role, but to a tactical role. So now, you know, our red flag warnings and fire weather watches and outlooks can help strategically pre-locate resources to an area of heightened risk. But now we're actually starting to tactically assist in routing those pre-deployed resources to the fire early, so that they can early and heavy and you know, really have a mitigating impact on some of these violent fire events.
Yeah, definitely. And I was going to say staging is really important. And I know you were saying that NWS played a role in that previously, but we actually sent a crew down to Childress for 2 weeks a couple weeks ago when they had the Amarillo fires, because we were seeing that. And they have the mutual aid program that's
right, TIFMAS.
Yep, yeah. TIFMAS.
Yeah.
So we sent 2 crews down there. And they were able to help that too. So
I can say beyond our fire weather watches and red flag warnings, the National Weather Service plays a big role in communicating with the state forestry agencies, certainly in Oklahoma and in Texas, and helping to target those TIFMAS deployments that you're talking about, Ashley. So we actually are providing experimental significant wildland fire outlooks that are probabilistic in nature, and may say that there is a 40% probability of significant wildland fires in the Amarillo area on 3 days from now or whatever. And some of that information is helping to guide some of the strategic thing from the state of Texas.
Yeah, and then I had one more question for you. So as an emergency manager who is currently working for our department, who has meteorology, forecasting background and schooling and everything, they want me to get really good at this because they're very excited about having that kind of resource. So what are some resources or any kind of thing I could tune into to enhance that? Because I will say, living in Lubbock and being a college student who loves severe weather, I really just paid attention to tornado forecasting. Yeah. So I could probably use some work on my fire weather forecasting. So what are some good resources for that?
Well, you're not alone. Most meteorologists in the Southern Plains have always been very heavily interested in severe convection and storms and tornadoes and the fire side of things. There was not a lot of work done on plains fire meteorology prior to the onset of these big events in about 2005, 06 and beyond. So, but since then we've made tremendous strides. There are a couple of resources out there. There are a couple of papers that there's a small working group of subject matter experts in the plains, and we have authored a number of papers, one in the electronic journal Severe Storms Meteorology on Southern Great Plains wildfire outbreaks, for instance. So you can look at that paper and kind of get the basic understanding of identifying these outbreak type patterns. We also have a relatively newer paper in the NWA Journal of Operational Meteorology on the low-level thermal ridge and how to use that to really focus in on an area of heightened risk and physically what's going on with the low-level thermal ridge. It makes it such a bad player for fire.
Well, perfect. Thanks for that. I look forward to looking into that.
I sure can. Go ahead. Okay, well, the one particular channel that's specifically made for fire really is channel 7, the 3.9 micron. It's a shortwave IR channel, and that is probably the default tool that we're using with GOES 16. There are, like I said, the fire temperature RGB, which is really cool. That's the example I was showing in the animation. Looks really, really ominous when you see a good fire on there. A lot of the derived products like firepower, fire size, those algorithms, from my understanding, are still being kind of tweaked and calibrated to GOES 16 because they were actually designed for legacy GOES. So they're still a work in progress. And from looking at fire activity in the West this past summer, they still need some tweaking, and they're being tweaked. One thing our forecasters have had a lot of success in finding fire very early is looking at what's known as the fog difference channel, which is basically the 11 minus 3.9 micron difference. And with that particular channel, it seems to be very sensitive, and you can see fires really early while they're still fairly small. In fact, in the last year, on 3 separate occasions here at WFO Norman, we successfully helped dispatch crews to structure fires that were previously unreported. I have not looked at that in close detail for fire, so I would have to withhold judgment on that one.
And I have one more for you, Todd. If I am a viewer watching this show, if I live in that area and there's a major wildfire ongoing, what's the best way that I can get plugged into what's going on? You know, a lot of folks, they're on their phones. They're not really watching TV necessarily. You know, they're just kind of living out of their phones. When you issue your warnings or your products, do they automatically go out to the phones, or do people need to go into their phones and activate that? What's the process that people can know what's going on without out in the news at the last minute or see something in the air?
Yeah, I would say local media and listening to your local officials is still the best means of communication to get real-time fire information. During these fire events, both Texas A&M Forest Service and the Oklahoma Forestry Services are very active in social media, especially on Twitter and Facebook. You can get updates that way, but definitely the local, broadcast media or media online via social media is definitely the best way to get the most up-to-date information. And of course, if it turns into an emergency type of event and your home or your community is being threatened, just listen to the local emergency management and law enforcement officials.
And Todd, my last question for you is, we've got Go 16 now going. What do you think the future is for forecasting these wildfires? Do you see anything else down the pipeline, or anything you guys are kind of working on to get the forecast better and to kind of really hone in on this?
Well, it's an exciting time to be working on wildland fire, not just here in the plains, but all across the country, really, because there are some exciting things. You've got the new generation of GO satellites 16 and 17, which has now been launched. So that's really going to revolutionize the way we handle fire, no doubt. There are other things too from a broader picture forecast perspective. Some exciting things that are being done at the Fire Sciences Lab in Missoula. Gentleman up there, Matt Jolly, scientist there, that's been working on something called the Wildland Fire Assessment System. It's a gridded kind of fire danger system that forecasters will be able to access and utilize to help forecast areas of heightened risk as well. So there are some innovative things occurring, in the wildland fire communities, specifically in areas of operational fire forecasting for the National Weather Service and beyond.
Okay, I do have one more.
Okay.
You just brought up a good point. Can you see these fires before they're actually reported? And can you be the ones to actually report to the authorities what's going on at what time?
In some cases, we absolutely can and have been on multiple occasions. Like I said, even recently picking up on structure fires, and that's pretty amazing when you're talking about an instrument that's 22,000 miles away and it's seeing a house burning in central Oklahoma. But we are, in many cases, catching a signature in the shortwave IR imagery before local 911 calls are received at a local jurisdiction.
And Todd, speaking on that, I know we talked before this show, you guys have partnered with the Oklahoma Emergency Management. You guys are doing some cool things with those folks as well, with wildfires and with the GO 16 data.
That's right. Some of the folks there, Zach Stanford and Daniel Piltz, have been instrumental in helping us with this wildfire detection, or what we call hotspot notification system that we're using here. And it's, direct feedback during periods of active fires here in Oklahoma and in Texas, and even now expanding into Kansas. The direct feedback we're getting from the EMs is certainly along the lines of, this is saving lives and saving property.
Very cool. Well, I know we don't want to keep you all night. I know we could continue talking about this, but how can our folks get a hold of you or kind of see, do you have a Twitter account you want to push out, or just the forecast office there? What social media accounts can they follow?
At NWS Norman, and my email address is todd.lindley@noaa.gov.
All right, Todd. Well, we appreciate you being with us tonight. I thank you for that. I'm glad our internet was able to stay up throughout the show.
Success.
It is, and good luck this spring season. Hopefully you guys aren't too busy there.
Well, thank you. We appreciate that. Thanks.
You're welcome, Todd. Well, we're going to skip tweets of the weeks tonight because I think Jared's technology side is kind of going crazy. So we'll get all the bugs fixed with that. But we do want to again extend our appreciation to Todd tonight for joining us on the Carolina Weather Group. And that wraps up our portion of the National Weather Podcast Month here. It's been another great month of sharing it with all of our weather podcast friends. I know tomorrow night the Weather Junkies will be featuring Peter and Eric from the Carolina Weather Group on their show Thursday night. I think it starts at 8 o'clock. And just follow Weather Junkies on Twitter you'll be able to kind of pull up that show and listen to it. Eric and Peter do as well, as we kind of finish out the weather podcast month. And then next week we have John Jensenius on. We're going to be talking about lightning safety. We're going to kind of be going into severe weather mode here in the Carolinas and throughout the Southeast as springtime really kind of peaks up everything. So we're going to be talking about lightning safety next week with John Jensenius. And then we don't have a show scheduled yet for the 11th of April. And then for the 18th, we have one of Jared. I know Jared's working on a guest as well, kind of talking about the some cool things that we're doing with lightning and stuff on Go 16. So that's what we're looking at for the next few weeks. But until then, we hope that you will continue to follow us and share the word about the Carolina Weather Group to your friends and family. And be sure to iTunes or Stitcher or your Google Play Store to our podcast, and also subscribe to our YouTube page so you can get updates about when we go live. So for everyone here at the Carolina Weather Group,